Okay, so this is going to be a review of sig figs. And as we did in class, I feel like one of the easiest way to do this is to just do this by example. And remember, as I did, let's do it in two different categories. Let's do greater than 1 separately from smaller than 1, because it's sort of the same idea, but they're sort of flip sides of each other. So let's start by just talking about how many sig figs each of these examples has. This, pretty easy, has 2. I'm sure you'll guess this one has 3. What gets a little more confusing is what do the zeros mean? And for numbers larger than 1, you really have to pay attention to the decimal. If you don't see a decimal, you assume the 0 is only a multiplier. Therefore, only the 2 is significant. You don't know if that's really 200 exactly, or 195 rounded to 200, or even worse, 180 rounded to 200. So we do the benefit of the doubt and assume it's the least significant. However, if there is a decimal placed here, we assume that that could have been written as 2. So why would the person have added all those zeros? Because 2 is no bigger than 2.00. Therefore, that decimal is communicating accuracy. So that has 4 sig figs. Once a number doesn't end in 0, then every number is significant as well. One tip, either in interpreting or communicating sig figs, is to simply write it in scientific notation. Every number in scientific notation, the first numbers communicate the accuracy, so that's 3 sig figs, and then the second part is the multiplier, as these zeros do. So now let's take a look at the opposite case, which is less than 1. So again, you might think that the first example is pretty easy, which it is, 2 sig figs. The second one as well is pretty easy, 3 sig figs. The reason I contrasted less than 1 and greater than 1 is that we had zeros as multipliers here. Well, here zeros do the same thing. Instead of a multiply, well, you're multiplying by a tenth or a hundredth. So therefore, instead of all 5 numbers are significant, only 3, the 2, 4, and the 5 are significant. However, we ask ourselves the corollary question here. 0.21 is no smaller or larger than 0.21000. Therefore, that scientist is communicating accuracy with those zeros. Therefore, this has 5 sig figs. In the next example, I'll let you take a guess what that is. You're right, it's 4 and not 7. And as in the last example, scientific notation saves our butt, and this is very simple. It's 3. It clearly tells you how many in the first digits and the last digits, or the multiplier just tells you what you're multiplying by. And I'm guessing the easiest part of this lesson is what do you do once you know the sig figs. If you have one piece of data that has 2 sig figs and another that has 3 sig figs, and you multiply the 2 together, your answer then needs to be rounded, not simply truncated, but rounded to, is it going to be 2 or 3 sig figs? That's right, 2 sig figs. The accuracy of your answer is as accurate as your least accurate piece of data. So always round to the least accurate piece of data.